Selamat pagi semua. Baru 15 orang Mana yang lain Tak tahu. Jom. I give another 1 minutes lah kot untuk kawan-kawan kita ni. Okay, I guess we should start off sebab Shan nanti lama sangat tunggu kan. Tapi maybe boleh bagi tahu kawan-kawan yang lain yang mana yang tak ada lagi. Semua dengar ke?
Dengar.
Alright, thank you Atika for the response. Alright, macam mana perasaan semua after 1 week cuti, after 2 weeks MTA? Ke macam dah tak ada mood nak kelas dah?
Still surviving.
Still surviving. Yelah. Itulah, believe it or not, you guys are midway through the semester lah. So macam nanti pejam cilik, tiba-tiba dah habis dah semester. So nanti you guys are getting closer towards finishing your degree lah. Dan nanti tiba-tiba rindu kan, bila dah habis yang degree nanti. Korang boleh kata survivor lah kan. Alright, cool. So let's get someone to baca doa. Kita nak siapa baca doa hari ni? And of course yang Muslim boleh baca doa sendiri. So Alif Firdaus boleh?
Boleh.
Okay, cool.
Bismillahirrahmanirrahim. Al-Fatihah. Allahumma aftah alaina hikmataka wa nashur alaina birahmatika ya arhamar rahimin. Rabbi shrah lana sudurana wa yassir lana umurana wa halul 'uqdatam min alsinatina yafqahu qawlana. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzabannar. Wa sallallahu alaihi wasallam Muhammad wa ala alihi wasallam. Alhamdulillahi rabbil alamin. Amin.
Thank you very much, Alif. Let's hopefully a new tone for our next 7 weeks to come, insyaAllah. Before kita tamatkan kita punya semester 5 untuk korang kan. Okay, so I guess before kita start, nak jugalah tahu korang punya feedback on MTA. How is it? Ramai yang kata tak cukup masa. Ke sini.
Ya doktor, tak cukup masa.
Tak cukup masa. Tapi dapat jawab semua soalan kan? Ke tak? Ada orang lain rasa macam mana? Susah sangat ke? Ada part yang macam memang tak boleh langsung jawab ke? Ya, macam terus tak ingat kan? After habis MTA terus delete. So Madam saya tak ingat apa-apa. Senyap je semua.
Curve to middle.
Curve tu. Soalan 2B tu kan. Itulah saya perasan macam ramai tak jawab soalan tu. It's actually quite straightforward. Macam sama macam sampel yang saya tunjuk waktu tutorial. So what you have to do for that basically is kita kena shift kita punya cold composite curve tu pergi below kita punya hot composite curve. And bila kita shift tu, kita kena make sure delta T min dia 10. And dia memang graf dia nampak sedikit pelik kan. So nampaklah macam ramai yang confused, tak tahu macam mana nampak kan. So basically dia just tarik and then you buat dia punya new curve so that you have a composite curve macam tu lah. So and ada yang soalan dia ada yang threshold juga kan. But then it's okay. We can discuss that a bit more later kot, insyaAllah. After I finish marking sebab tak sempat lagi nak siap marking semua sebab nak tengok apa lagi komen-komen lain. Kalau dari segi soalan lain boleh ke? Okay ke? Ke macam panik tak tahu macam mana nak jawab? Ya, boleh lah juga jawab tapi takut salah.
Faham.
Alright, that's okay. Thank you for the response. It's good to know you guys didn't give up. I think ada a few people yang dia mungkin tak tahu lah dia tak sempat jawab ke dia tak hantar, but nanti I'll contact them personally to check balik. But good job again sebab you guys already accomplished it. It means that you guys already overcome the hurdle. Maybe in terms of time tu, we can actually try to do more practice questions supaya nanti kita boleh do it faster lah, especially coming towards kita punya exam nanti. Okay, so before kita start, I actually think macam tutorial hari tu was quite tutorial hari tu was quite a long time ago, but I'll just answer 2 questions kot yang I think I tak sempat jawab from the previous tutorial, and I think I should be recording somewhere. Recording. Recording untuk kawan-kawan kita yang dapat join. Macam 25 people, so 24 people, getting a bit better. Okay, so basically for the questions, I did 2 questions here. One is, I think I sort of answered already, but I'll just let you guys know again. Doctor, our network area will be different with other people because the graph is different. I got 7 sections only because I use a huge scale. So sebenarnya kalau untuk network area tu, you should get the same answer for everyone. If it's a huge scale, dia akan jadi less accurate lah. So it means that your answer will be less closer to the correct answer. Macam ada juga soalan tanya, for the area sections, do we need to also calculate the area even though the section is too small? So yes, you do have to calculate it. Kecil macam ni pun kena calculate juga. So hopefully that can help out with your assignment lah. And I hope that you guys can sort of get that finished by today. And kalau apa-apa hiccups lagi, just let me know. So if there ada anything tak you guys want to ask or say or get off your chest before kita start kita punya lectures today?
Ada kot doktor? Tak ada.
Tak ada Alright, thank you very much for the response. So itulah for those yang ask me questions personally, that's good. It's good to always check your understanding balik lah. Okay, so we have 7 chapters as I mentioned. Kalau kita perasan, kita dah go over the huge chunk of our whole entire course. So chapter 1 dan chapter 4 ni memang core dia lah. chapter yang lepas-lepas ni pun core juga. Cuma without the first 4 chapters, you won't be able to understand or grasp the next 3 chapters. So kalau masih ada part yang tak faham, and I hope when I finish marking MTA nanti, I can try to see lah part mana yang you guys still lacking and mana kita boleh try to figure out sama-sama before the final exam and before the course ends. So a recap, we find the energy targets to get the best sustainable punya, to get the least amount of utilities required. So that's chapter 2 kan. So chapter 5 ni dia akan relate balik dengan chapter 2 sebab dia akan we are going to decide what utilities that we want to use. So when we're saying kita nak guna hot utility, is it going to be high pressure steam, low pressure steam or medium pressure steam? So dia macam kita nak cuba detect what type of utility kita nak pakai. So these 2 chapters sebenarnya is going to involve a lot of reading juga. So I will actually hope that you guys can actually read it through your textbook a lot lah, and then kalau ada part yang tak faham, we can go through it together lah. So I won't be teaching you everything, but you can get everything from your textbook. Hopefully I'll just explain the main concept lah. Okay, so process utility system ni kalau korang ingat onion diagram, it's the outer layer, so reactor, separator, and then we have heat exchanger network and then the next one is kita punya utility. So bila kita dah settle kita punya heat exchanger network, you want to start to consider what utility you want to use. And when we're talking about utility, we're talking about what you want to supply into your plant. Okay, so that's why you would consider the next layer lah untuk kita punya onion diagram. So we're working outwards from the basic end. So kita nak tahu, this is what we want to learn for this particular chapter and for this particular lecture. Kita nak tahu macam mana nak letak utilities and macam mana kita nak optimize cost tu supaya kita tak membazir. We also want to optimize the use of proper utilities untuk reduce kita punya cost. And last sekali kita akan tahu macam nak buat GCC. So grand composite curve je. Another composite curve, and so we're going to do another graph lah untuk tengok macam mana kita nak target utilities. So yes, it is an important chapter, a huge chunk. Macam previous semester ramai orang selalu rasa this chapter is a bit harder. Basically because dia ada banyak theory juga, but at the same time it's also if you understand the concept, it'll be easy for you lah. Okay. So itulah, so kalau korang rasa macam penat kan dengar saya cakap je, just let me know and we can have a break in between lah. Okay. So going back to understanding what utility is, lepas kita dah buat heat exchanger network, kita akan ada heating and cooling duty. So kita akan ada QH min and kita ada QC min. So whenever I'm talking about utilities, I'm actually talking about this. Okay. So when kita ada QH min and QC min, contohlah kita ada QH min of 300 kilowatt and QC min of 100 kilowatt. So what we want to do is we need to supply this from a utility. So utility basically is macam kita punya electricity, kita punya, so if hot utility kita ada high pressure steam, low pressure steam, medium pressure steam and low pressure steam. And for cooling kita ada cooling water, kita ada refrigeration. So there's a lot of different types of utility. Okay, so there's 2 types lah, mainly hot and cold untuk kita punya QH min and QC min. So if you still don't understand what QC min and QH min is, it's basically the minimum amount yang kita perlu supply daripada luar. So kita dah ada kita punya process, we already integrate the process, kita dah dapat, we already get to recover some heat from the hot streams and recover and cool down some hot streams from the cold streams. So kita still perlukan tenaga daripada luar. So that is your energy targets or your QH min and QC min. So kita kena supply as a useful utility. So everything ties back together. So bila kita cakap hot utilities, we're talking about what we need to use for heating requirements. So macam mana kita nak panaskan the remaining streams yang perlu. That's why kalau kita tengok graph, dia macam ni. So basically this stream kita perlu panaskan kan. We need to heat it up. So how do we want to heat this up? So ni composite curve kita kan. So how do you want to heat it up? Biasanya macam kita pakai boiler ke apa kan. So most commonly used is a steam lah. So that but if it's a higher temperature, we can also use flue gas ataupun hot oil. Sebab apa, steam dia punya maximum temperature pun is not that high lah kan. You can use saturated steam macam mana kita belajar dalam thermodynamics ataupun your CPP and your chemical principle process. Good, CPP. And which I think korang dah belajar sebab ada CPP 1, CPP 2 kan. So ideally kita nak cuba guna dekat lowest level sebab dia lagi murah, dan kita nak generate at the highest level. So this is one of the questions in MTA kot. Soalan dia release a lot of energy. So actually you can actually use the energy release to generate steam. So when you generate steam, dia jadi satu type of utility. And I think not a lot of people boleh jawab lah soalan tu. But then we'll talk about that a bit later lah juga. So this is the utility punya relative cost. You have cooling and heating respectively. So if you see, kalau when the temperature decreases from room temperature, you require more money lah sebab dia perlukan a lot of cooling. So at -70, the cost is really high lah. Sama juga macam heating. So when you heat it up sampai ke, and usually kadang-kadang kita boleh sampai ke 800 or 1000, you would require a more amount of cost lah to be paid for that particular utility. So ni semua straightforward je kan. So this is basically how you can supply your utilities. So you basically can use macam saya sebut tadi lah, you guna fuel untuk you punya high pressure steam, you supply through your steam turbine and into the process. Or so Q ni as your energy lah, or your medium pressure steam or your low pressure steam. So this one kita biasa tengok kepada plan kita lah, and when you start doing your intern, dia macam akan best lah sebab if you can ask your supervisor and tanya, oh kalau plan kita pakai utility apa, so sometimes they would bring you around to see the utilities lah and show how it's actually being used for this particular system. So memang mana-mana plan memang akan ada utility punya component of it sebab kita perlu provide energy towards it and so you have your furnace. So furnace you panaskan fuel and to give you energy, and the heat release you can use as your air preheat untuk panaskan. Sama juga your cooling tower, you put your cooling water into your cooling tower, or you can use your refrigeration. And basically this gas turbine and heat pump lah yang kita akan tengok, I think it's in next chapter. Macam mana next chapter or next week, macam mana kita nak utilize these two for our utilities. Next week kot. Okay. So ni satu lagi typical steam plant. Maksudnya dia ada high pressure steam. So dilalukan kat turbine, you get some work generated and then you release intermediate pressure steam. So IP steam is intermediate pressure lah. Ataupun sama juga lah. And if you step down your intermediate pressure steam, you can get your low pressure steam. Macam tu lah, and then you put it through the condenser. So this one I think you guys have already seen for other courses juga. So it's just pretty much a revision lah. So these are the typical steam boiler. Maksudnya what are the pressures for the steam for the power generation. So 100 bar gauge, 40 bar gauge. Depends on what you want to use for your particular plant. Biasanya kita akan pakai steam untuk apa kan. So you can read on this. Obviously kita nak pakai steam untuk indirect heating. Itu paling obvious lah. Kita boleh guna juga untuk steam tracing, direct heating, creation of vacuum. So banyak benda lah, banyak function lah sebenarnya steam ni. So biasanya kita tengok steam table kan, kita punya thermodynamics steam table. So basically we know that macam mana steam tu can be supplied, but then how is it used? So sama juga kat sini, you can basically have a read on that. How we actually want to use the steam and provide it. So ni pula refrigeration. So refrigeration, you can use cooling. So macam ni sistem dia kan. So basically dia macam mana dia dapat daripada cooling water ni. So it's from the turbine kan. Dapat cooling water and then you provide it back to the process itself. Okay, so you can read again through that lah. And I think this is an important slide. Basically pasal dia punya temperature. So it tells us kita punya high pressure steam, medium pressure steam, low pressure steam, berapa temperature yang kita typically boleh dapat. So when we know kita perlu ada QH min of macam tadi kan, let's say 300 kilowatt, kita nak supply medium pressure steam ke, high pressure steam ke, low pressure steam ke. So basically it depends on what temperature we require to heat it up to. Macam tadi yang saya lukis graf tu kan. So contohlah kalau saya lukis graf kat sini kan, kita punya QH min. So let's say this is at temperature 200 degrees Celsius. Agak-agak what type of utility that I can use? Yes, correct. So kita akan tengok sini sajalah. Thank you for the response. So you just use medium pressure steam. So it depends on the temperature that you are required for that particular system lah. And if you know steam dia ada limit, so above 260 kita akan biasa pakai hot oil dengan flue gas, which is a bit different lah. Kalau cooling water pula, if it's less than 10 degrees, you need to use refrigerant lah sebab obviously you need to make it colder than it is lah. Okay. So macam ni kita nak tahu what is the best mix of utilities that we can provide to the system. So that's how we learn using our grand composite curve. And grand composite curve ni basically is an extension towards your composite curve and your PTA, your problem table analysis, which korang dah buat lah. So this is part 1 of our chapter 5. Macam mana nak lukis grand composite curve. So kalau kita tengok kita punya previous lectures, and I think ramai yang jawab. So I think there was one question talking about the difference between composite curve and problem table analysis. I think ramai dapat jawab, tapi at the same time ramai yang kurang clear dengan that what it means. So when they say advantage and disadvantage, basically you say apa kelebihan composite curve, and so you can see things on the graph. It's easier to shift the graphs if you need to change dia punya delta T min. I think tak ada orang kot jawab yang tu. And then in terms of PTA pula, it's easier because it's calculation you can use for a lot of streams. Sebab ramai yang jawab CC you can use for many hot and cold streams, which is actually the same thing you can do for PTA. Okay, tapi tak apa, tu selingan kan. Kita boleh guna CC kan untuk buat energy targets, tapi dia tak boleh dapat selection of utility. So from CC alone, you don't know what type of utilities that you can provide or you want to provide to the system. Sebab tu kita kena belajar GCC. GCC ni I think is really important sebab it's very common practice to use in your industry lah. So bila korang dah kerja, you might, if you're working with utilities, you will be seeing GCC ni macam korang punya makanan lah. Because you would have to consider what type of utility you want to use. So kalau korang intern nanti, korang boleh lah yang tunjuk kat supervisor korang yang you guys already know how to do this and more importantly untuk korang punya design project in semester 7 you will also need to use this lah. So basically kita nak cuba understand apa dia punya interface between the process and the utility system. So sebenarnya walaupun nama dia composite curve, kita plot GCC kita. So grand composite curve kita guna problem table analysis. So guna cascade yang diberikan. Okay. So this is an example of a problem table cascade. So we're talking about a problem table cascade. It's the last step of your PTA. Okay, bila kita dah dapat PTA kita dah dapat mana zero, kita dapat pinch kita, that is your problem table cascade. And it's also, ada juga soalan 2B kot dalam MTA yang dia dah bagi problem table cascade tapi ada some of you still buat PTA balik. So sebenarnya dia dah bagi dah QC min, QH min dia dengan pinch. Tapi you guys buat balik, bukanlah semua, tapi ada lah yang pergi buat balik PTA. So I think that's why banyak hilang masa lah sebab sebenarnya tak perlu pun buat, dia dah bagi dah. So benda-benda macam tu also have to check balik lah before going through other assessments supaya you guys can actually not waste a lot of time lah on things that have already been given. So ni problem table cascade yang apa yang dah dapat dekat your QC min, your QH min dengan your pinch min. So from this problem table cascade, kita akan gunakan untuk represent dia punya heat flow. So you want to make a graph of temperature interval. So this is very important sebab kita akan guna temperature interval, not the actual temperature, with your delta H. So basically dia akan plot just based on the value yang ada. So kalau 55 sini kita akan plot 55 lah. And then if it's 80, kita plot 80. 40 and then 0. So tu graph dia akan dapat. Okay, so very easy, very straightforward. Should be easier to do lah later. So macam mana dia relate dengan composite curve? Kalau korang perasan, basically what happens is that kita kena shift kita punya graphs together. So that's the function of kita buat PTA kalau if you guys remember. And then kita flipkan graph ni. So yang kat sini kita flip pergi sini. So that's why dia akan dapat these values. Cuma it's easier to see mana dia punya pinch and where you want to supply the suitable utility. So you can see what temperature is required lah and how and where do we need those utilities lah. So then we're going to use another term called pockets. So kita akan tengok kejap lagi. So contohnya kat sini, bila kita punya composite curve, kita akan ada kat sini pocket. Dan kita akan ada kat sini pocket. Okay. So kita akan tahu pocket ni, what it means is basically kita akan ada hot stream yang cukup untuk panaskan kita punya cold stream. Tapi bila kita ada this part, we know that's the amount of hot utility. So we need something to heat up these streams. So that is your grand composite curve. Sama juga dengan kita punya cold composite curve. You need something to cool down these streams. So basically based on this, kita boleh tengok what temperature is required. So the temperature dekat sini would be what utility that we need to use lah for that particular process. And kita akan see kejap lagi. Sorry, ni pockets of additional heat recovery. So macam ni lah pocket dia kan. So di sisi dia tunjuk the hot and cold utility requirements untuk both process. So dia akan tunjuk lah kita punya energy targets with the respective temperatures that we require them for the utilities lah. So tu yang kita ada QC min dengan QH min tu tadi. Okay. So ni contoh utility placement. So macam typically kita akan tengok, kalau kita tengok macam ni, okay, madam kenapa kita nak kena consider pasal utility lain? So kita bagi je lah ikut apa-apa. So one utility kan. Tapi sebenarnya kalau kita tengok graph ni, if you see, if kita supply fully high pressure steam, let's say kalau high pressure steam harga dia is around contohlah $60. Contoh so $60 per kilowatt kan. Kalau medium pressure steam is maybe around 30 kilowatt, $30 per kilowatt, and say low pressure steam, it depends juga on where you get it and how the quality of it lah. So contoh low pressure steam is about $10 kan. So contohnya kalau kita punya QH min is contoh 300 kan. Mana yang akan lagi murah? A ke B? It's the same graph. So sini pun sama. QH min dia 300. B kan? Sebab dia akan guna lot of less power steam. So sebenarnya low pressure steam kan. So sebenarnya bila kita buat GCC, we're going to use, instead of kita bagi semua high pressure steam, kita akan letak sikit low pressure steam, sikit medium pressure steam and sikit high pressure steam. Yang penting it's enough untuk heat up proses ni. Okay. Tapi kalau kita perasan kat sini, kita tak boleh lah bagi semua ni low pressure steam. Jadi kalau nak murah, saya pakai semua low pressure steam lah. Tak boleh kan, sebab this temperature is higher than your low pressure steam. So tak boleh lah nak provide kan. So kita akan bagi medium pressure steam. Tapi tak boleh bagi sampai semua sebab yang ni perlukan higher temperature. So that's why I use high pressure steam. So dia very very straightforward lah benda ni kan. So kita nak tengok macam mana kita nak lukis kita punya grand composite curve. So before kita go into that, ada any questions tak sampai sini? Senyap.
Tak ada.
Tak ada. Okay, cool. So alhamdulillah kan, quite straightforward and this easy and sebab dia teori kan. Ataupun harap beli you guys tak tidur lah sebab bosan kan. So ni kita punya grand composite curve. So the steps are basically a continuous part from sebelum ni juga. Kita akan extract and complete a stream data. So that is what you've already done before. Kita akan tengok mana satu hot streams and mana satu cold streams and we have to complete it. Mana-mana value, kalau tak ada value CP, kita cari value CP kan. So ni korang dah pro lah, I'm pretty sure. Untuk yang dua ni pun insyaAllah korang dah pro juga kan. Kita perlu buat PTA untuk dapat Cascade. So this is basically getting your energy target. Dapat last step tu, you would then use that PTA untuk plot kita punya grand composite curve. Okay, lepas tu kita akan shade your heat recovery pockets and draw the line for hot and cold utility. So tu je sebenarnya. Kita extract and calculate the loads for each of the hot and cold utility. So this is benda yang paling penting lah. Exam last semester macam ada orang dia dah buat GCC, dah siap dah. Tapi part 6 ni, nombor 6 ni dia tak buat, which is dia just tak bagi tahu berapa banyak high pressure steam you want to use, berapa banyak medium pressure steam and low pressure steam you want to use. And this is your final answer lah sebenarnya, to make sure that you get get the full marks lah. Okay. So ni contoh an exercise that we can do together for us to check the understandings. So dia kata kat sini, based on the strings below, draw dia punya grand composite curve kan. So dia bagi delta T min and dia bagi 4 streams. Okay. So for 2 levels of steam at saturation condition and temperatures of 240 and 180. So dia dah bagi tahu kita, we have 2 steam levels. Determine the loads on the 2 steam levels that maximizes the use of lower pressure steam. So sekarang ni, so basically apa yang dia cuba cakap is that find the best utility placement for the lowest cost. So sebab tu dia kata maximize the use of lower pressure steam sebab it's cheaper kan. So for 240 and 180 degrees, what pressure steams are we looking at? High ke, medium ke, low? Sure. So kita tengok balik yang ni. So sebab tu saya cakap yang ni penting kan. So still with high and intermediate? Okay. So technically kita boleh guna sini kan, high kan. So 180 you can use either low ataupun medium pressure steam lah sebenarnya. Okay. So when we go back here, so you can, so sebab tu dia kata lower pressure steam kan. So anyway, let's just use high pressure steam and medium pressure steam. Okay. So that's basically how we want to determine what types of utilities. Kadang-kadang dia tak bagi benda ni. Kadang-kadang dia bagi. So it depends on the question lah. So we have to choose what we want to use. So bila kita dah buat kita punya PTA, so this is the last step of PTA, ingat bila kita dah dapat kita punya, so we already do the first cascade, kita dah calculate semua streams dia, we already got dia punya T interval, dah dapat dia punya difference, dapat dia punya QC, sum of your CPC minus sum of your CPH, and you get your cascade and you get your pinch. So this form is one form to see it, another form is in form of table. So ni kot yang diberi dalam soalan dalam MTA yang macam some of you couldn't understand kan. So bila dia kata 0 kat sini, this is your pinch lah. So samalah dengan benda ni. So this is your problem table cascade. So you get your QH min, your QC min, and then your P pinch. So when they say PTA cascade, this is your PTA cascade lah. So kita akan plot kita punya GCC. So plot kita punya GCC, remember we're looking at your temperature interval versus your delta H. So just ambil table ni, kita akan draw your x-axis and y-axis. So plot je based on the value. So 750, kita ambil 750 kat sini, kita pangkar. 900, so it's 900 sini, kita pangkar. 300, so 300 sini, and you just connect the lines and you get your GCC. And your pinch here should be the same as this temperature here. So 145. So kita akan ada above pinch and below pinch. So okay ke sampai sini? Senang kan?
Okay, Doktor.
Okay, thank you for the response. So basically after we get this, kita akan tahu yang kita perlu shape kita punya heat recovery pockets. So pockets tu is always going to be on your right hand side. So it has to be these ones lah. So kita buat line and kita shade kan. Kita shade this one and kita shade semua. So the reason why kita shade ni is to make sure that we know that there is heat being supplied for that particular process. So apa yang shade ni actually represents is that you have enough heat to heat up this stream. Sama juga kat sini lah. So this is what I said just now lah. So ni pun dah cukup kan untuk heat up that stream. So that kita boleh tahu mana actual utility that we need to provide. So bila kita dah shade, kita nak kena start to draw kita punya hot and cold utility lines. So based on the temperature given. So tadi temperature dia bagi berapa? Dia punya steam. Okay. So minimum pressure steam 180, thank you. So basically, adakah kita akan ambil terus dan plot dekat sini 220? Betul tak? Sebab apa Akasha? Okay. Betul lagi? So kita ambil 180. Sini. Betul ke ni? Kenapa? Betul, so it's wrong. So betul Akasha. Tapi apa yang salah is because it's using temperature interval. Okay. So ni adalah salah satu mistake yang I think a silly mistake lah. Bukan silly mistake, careless mistake. So kalau kita plot macam ni, jawapan kita dah jadi salah tau. So we have to plot based on dia punya temperature interval. So it has to plus minus. So if it's above pinch, so kita perlu kita perlu tambah kita perlu tolak. So we treat it like a hot stream. So kita akan tolak dia punya delta T min over 2. So ni sama macam PTA lah sebab dia temperature interval. So delta T min dia tadi 10, so divide by 2 we get 5 kan. So you should plot at 175 lah. So betul lah dekat bawah lagi. Tapi dekat sini lah, so 175 sini. Jawapan dia akan lain sikit lah kalau perasan. Macam tu. So you can, but it's a really good technique. Macam Akasha sebut kan, kita start daripada lower kan. So sini pun sama juga, 220 minus 5, so dia akan jadi 215. So 210, 15 sini lah. Okay, so basically yang saya tunjuk dalam ni, saya dah buat dia punya line kan. So you basically draw the lines. Kalau nak buat macam Akasha sebut tadi, which is start from your lower temperature is really good sebab nanti kita boleh tahu mana nak start. Tapi you can always just draw the line first untuk make sure kita boleh tahu exactly kan macam mana. So kita tengok kat sini tadi, so remember this one is 215. Betul ke? Bukan je 215. 220 240 lah. Okay, so it's 240 bukan 220. So ni 240. So it's 235 lah sebenarnya. So 235 and then yang tu 175. So bila kita dah draw line, basically what we want to see is you see that these streams can be heated up here and kita boleh juga heat up this stream kan. So we know where to start and stop lah. So kita akan calculate, so we want to extract and calculate the loads. So kita akan lukis macam ni lah. So kalau you guys dah buat macam ni, macam Akasha sebut tadi kan, kita start daripada lower pressure and then kita start daripada situ untuk buat kat sini is also boleh kan. So korang terus dapat korang punya jawapan. Okay, so berapa medium pressure steam and berapa high pressure steam yang kita perlukan? Okay, medium 300. Betul ke you punya high pressure 400? Berapa? Sure. 4.5 kan? So basically it's just reading the graph lah. So macam tu je kan. So kita dapat jawapan kita. So kita dapat 450 and 300. So kalau soalan ni dia hanya minta untuk steam kan. Tapi usually you have to calculate for dia punya cooling water juga. So cooling water usually is around 20 lah. So 20 degrees or 25 degrees. So depends on bagi. So kalau dia 25 degrees, so this one, so remember kalau dia bagi 25 degrees cooling water, you just want to minus and you have to make it hotter than it is. So kita akan buat dekat 30. So plus 5. So sebenarnya bukan kat sini. Ni kalau dia tanya lah, habis soalan ni tak tanya. So you get at 30 degrees kat sini. And sama jugalah. So this one heat up. So you would need basically 1000 kilowatt of your cooling water. Macam tu je. Okay. So this is the solution lah. So you can get 300 kilowatt and 450 kilowatt. So that is the loads, maximizes the use of your lower pressure steam. So tu je jawapan dia. Senang kan? Okay ke? Ada soalan tak? Untuk sampai this part.
Okay, Doktor.
Okay. So it's fairly straightforward, quite easy. Hopefully korang boleh sekolah kot part ni. So sayang sangat kalau tak dapat kan. So basically that is how you want to use your GCC lah. So kadang-kadang orang selalu confuse kan, adakah kena pocket? So sebenarnya you don't have to kenakan dia punya streamline to the pocket lah. So kalau kita tengok contoh yang ni mungkin satu contoh yang quite easy kan. Kalau kita tengok contoh ni, macam ni kan, dia tak ada kena pocket pun. As long as dia kena your GCC, then you would actually, so where the lines should be to represent mana yang awak nak heat up. So it should be towards your GCC lah. So sampai GCC je, you stop kan. And you have your next pressure steam, macam tu je. So that's okay, I'll let you guys do the examples, do the tutorials to actually see that properly. So semua orang okay ke untuk proceed with part 2? Ada soalan tak untuk GCC? Ke nak break kejap ke? Betul? To be honest, actually it's if you ask me, I would say to take the higher one lah, sebab macam you said just now lah, temperature can fluctuate kan. And if it's lower than the actual temperature that is provided to it, dia tak boleh lah dia nak heat up your process. So take the higher one. So macam tadi Akasha cakap guna medium pressure steam kan. So yes, if it's 180, I would suggest to use that lah. Sebab if you want to heat it up to 100, you actually require a lot more heat lah macam tu. Okay ke Akasha? Okay, thank you for the questions. Very good. Any other questions? Senyap je. Okay, so korang nak break ke? Korang nak continue ke? Macam mana? Nak break Okay. So let's have a 5 minutes break. Kita continue balik 9:20. So yeah, I'll see you guys in 5 minutes and feel free to grab something to eat ke apa ke, buat Milo ke, buat Nestum kan. And I'll see you guys kejap lagi. Okay ke semua? Sempat ke grab something?
Sempat Doktor.
Alhamdulillah. Saya sempat buat air je, tak sempat minum. Lambat sangat balik. Apa nama, ada seorang lecturer Queensland tu dia sangat punctual. So nanti kalau dia cakap 5 minit kan, dia buat kopi kan cepat-cepat dia terminum. So very very fast. I never know how to do that sebab panas kan air. So anyway, hopefully everyone is a bit recharged, dapat gula-gula ke snacks kan. I want to continue to the next part. Saya namakan je part 2 tapi sebenarnya it's continuous towards the GCC lah. So saya just nak bagi dia different parts so it's easy for us to digest lah. So, semua okay ke?
Okay, Doktor.
Okay Doktor.
Okay, Alhamdulillah. Thank you for the response. Cool. So, if we're looking at your GCC utility placement, macam tadi kita boleh buat macam ni kan. Contoh kan, tapi this contoh dia guna low pressure steam and high pressure steam kan. You can use 2 different utilities lah. But you can also use hot oil saja. So hot oil, proses dia sebab kalau steam dia saturated steam, you would get it at only one temperature. Tapi when we're talking about flue gas ataupun hot oil, the punya temperature would decrease as it actually transfers energy or heat towards the process. So sebab tu dia punya line jadi macam tu kan. So this is your hot oil utility lah. Okay. And then basically ni contoh hot oil. So basically we're going to see a lot of this theoretical flame temperature, your T stack and your stack loss. So you would, for your flue gas, you actually have to consider limitations yang ada. So dia tak boleh langgar dengan kita punya ground composite curve. It must be separate kan. So that's why kalau kat sini you punya T pinch would be your limiting factor. So that's why kita akan buat gradient based on your pinch point. And then but you actually have to provide more to consider dia punya stack loss. Okay. So kita kena provide more amount of fuel to consider dia punya amount that the energy that has been lost towards the process as well. So dia basically your releasing temperature lah sebenarnya your TO star ni, your T star temperature, T star O sebab you have to consider you punya acid dew point. So yang ni sebenarnya you can read on it. So I put some notes here. But you can also read in detail dalam textbook. Dalam textbook dia lagi detail lah. So basically dia cakap kat sini lah your pasal your T stack, your theoretical flame temperature. So what is it and so it's basically obtained when your fuel is burnt in air or oxygen without loss or gain and so mesti akan ada certain amount of gain and so dia kena be cooled to your pinch temperature before being released and bila kita release tu kita akan dapat kita punya stack loss lah. Like I said just now lah. So that's basically what you can see from this picture here. So the amount of fuel you can calculate based on the fuel required. You can calculate based on the amount of total that is required for the system lah. So kita bukan hanya provide, so tengok fuel dia bukan saja bagi QH min, tapi you have to consider dia punya stack loss. So the amount of fuel has to be provided more than your QH min. So sometimes maybe some people dia tak suka lah guna flue gas ataupun hot oil lah. Dia lagi prefer guna steam. So more about flue gas. So mungkinlah kita boleh cakap kan, kalau macam tu madam, saya nak kurangkan je lah steeping stack loss. So saya tinggikan dia punya flame temperature, theoretical flame temperature. So when we do that actually, kita akan reduce steeping stack loss tapi kita akan increase dia punya thermal efficiency. Tapi kita akan form nitrogen oxide. So benda ni adalah sangat-sangat dangerous to the environment and that's why some people dia choose untuk biar je dia punya stack loss besar supaya dia dapat save the environment lah. So it's basically a trade-off jugalah to decide what we want to use. So itu untuk flue gas lah. And again dalam textbook yang Robin Smith tu, you can read a lot lah on this flue gas and feel free to ask and if you have questions. So for hot oil ataupun flue gas, there can be other limits, okay? So macam ni kan, kita boleh tengok kalau graf dia macam ni, limit kita hanyalah kita punya pinch. Okay? Tapi kalau graf dia macam ni, you cannot do graph macam ni. You cannot do your flue gas macam ni. So flue gas tu akan langgar kita punya composite curve. So it must be a different limiting factor. So that is another limit lah. So the limiting is this GCC point kat sini. So kita akan buat based on this graph lah, that curve. So macam kalau korang perasan dia punya line could be a lot banyak yang berbeza, depends on what you want to achieve. So kalau kita buat macam ni dengan macam ni, basically you would see dia punya stack loss kat sini. Basically it would be easier kalau kita guna this value lah, which is whichever the steepest curve or the one which is closest to your limiting factor lah. So kalau macam ni pun sama, kita akan ambil based on your GCC. Okay. So more pasal utility placement. So pasal flue gas. So this is another type of utility placement. So this is the question that I mentioned just now. Ada soalan dalam MTA yang tanya what is the most suitable utility to be used and so you can actually, and I think I mentioned it in threshold problem code dalam chapter 3, yang basically you can generate steam kan. So kalau dia punya pinch is very high, you want to cool down this end. So kalau kita nak cool down stream ni, sebab sini ada pocket, so tak ada masalah kan. So kita nak cool down and kita perlukan this banyak kan. So contoh kan, kalau kita pakai cooling water untuk semua, so cooling water untuk daripada sini ke sini, dia jadi sangat-sangat rugi sebab temperature ni is actually a useful temperature. So it's 180, dia adalah above boiling point. So we can actually use it to generate steam. So kita akan lalukan boiler feed water and then kita akan dapat steam at let's say 120 degrees Celsius. So kita boleh guna lah untuk other processes. So you can actually generate steam below pinch and that can be one of your cooling utility. So tak semestinya cooling hanya guna cooling water ataupun kita punya refrigeration. So you can also consider to use it to generate steam. So lalukan air biasa untuk dipanaskan steam tu so that you can actually use it for other processes. So that is more sustainable lah. Okay. You also can consider steam generation with boiler feed water and preheat and superheat. So ni yang saya sebut tadi, boiler feed water. So kita akan preheat dia sampai saturated steam and then kita akan superheat dia. So you can basically, so kalau kat sini and nanti kita akan tengok in your tutorial punya soalan, I gave something similar to this. So you can sort of see how you can calculate your boiler feed water. So dia punya points, again dia tak boleh langgar kita punya GCC lah. So nampak kat sini dia ada limit S2. So point of closest approach is not necessarily your boiling point lah. So it could be anywhere along your boiler feed water. So you'll see that a bit more in the different question. So this is another, when we're talking about utility placement, this is another thing that you can utilize lah. So kalau pocket dia sangat-sangat besar, so tengok pocket dia very very big until it actually expands over 2 utility punya temperature. So dia spans over 2 utilities kan. We can actually use it to generate steam. So contohnya kat sini, dia boleh generate high pressure steam. So dia kata, oh kalau macam ni kan, better aku utilisekan proses yang kita ada because it's useful heat. So that's why dia akan gunakan high pressure steam tu untuk to generate high pressure steam. And for this particular process, so dia nak panaskan ni kan, so dia replace dengan supply low pressure steam dalam sistem tu. So kalau dia nak kata, oh it's more useful for me to, contohlah ni hanya 100 kan kilowatt, so ni lagi 100. So contohnya it's more useful to get 200 kilowatt of high pressure steam and then guna, so produce, yang ni use and then guna 100 kilowatt of low pressure steam. So kita produce ni kita boleh either kita jual ataupun kita guna untuk other process. So it's a lot more sustainable. So they can decide to do that as well. So it depends on what kita lah as an engineer, we have to do the calculation lah, dia punya trade off with the cost, which one is actually better. So itu kita punya optimization on how we want to make the utility price actually the best and for the system. So you may be asked to do that. And So itu hanya kalau pocket dia very big lah. So you can actually consider that. So kita boleh juga, contohlah, oh madam, adakah kalau saya pakai flue gas, saya hanya perlu pakai flue gas saja? So you can actually mix it. So you can use flue gas, or you can use flue gas and low pressure steam and flue gas. So you can supply to see mana, so basically kita akan tengok mana yang best cost effective lah. So mana yang paling murah. Okay. So when this is another thing, which is a utility pinch. Each time the utility profile touches the GCC, a new pinch or utility pinch is created. So kalau disentuh GCC, dia akan dapat kita punya utility pinch. Jadi kita tak belajar dalam our syllabus, but you might be seeing it in the industry. So macam saja tunjuk you guys as well. So bila kita buat utility pinch kat sini, so we can see lah where's the utility pinch. So you can't see it. Basically kalau kita dah buat GCC, kita tak nampak mana utility pinch. That's why kita akan gunakan balik dalam you punya composite curve. So bila composite curve, kita akan nampak oh sebenarnya ada pinch lain. So kita akan lukis balik ke dalam CC and dapat balance composite curve. But again, this is not in the syllabus, but it's also just for you guys to know lah, supaya you can actually bila nanti dalam korang buat intern ke apa kan, tak ada macam benda ni kenapa dia punya pinch ada banyak kan. It's basically because you have your utility pinch from your GCC kan. So this is the balanced composite curve. So you see again ni macam mana kita dapat dalam heat exchanger network area hari tu. So hari tu mungkin macam easy kan sebab dia just bagi hot composite curve and cold composite curve. But you can also see stuff like this lah. Dia generate steam. Dia using flue gas, requires cooling water. So basically these are basically your balanced composite curve lah. Kita dapat semua pinch including your utility pinch, and kita dapat semua utilities yang digunakan. So hari tu kita hanya lukis cooling water dengan steam kan. Tapi ini dia tunjuk dia pakai steam dekat mana, dia pakai flue gas dekat mana. So dia just compresskan balik kita punya GCC. So it's easier for us to have lah untuk the plan. So kita nampak lah proses tu particularly kat mana diguna apa kan. So this is another exercise. Sampai sini ada soalan tak? Hilang dah semua.
For now tak ada aku Doktor.
Okay, thank you. So tadi tu banyak teori kan, dia susah sikit nak, it's basically we just have to listen kan, macam bosan lah kelas kan. Tapi this is the way, this is an example calculation yang kita boleh buat lah. So dia kata instead of using steam, so it's the same question tadi, instead of kita guna steam, kita guna hot oil circuit. So dia bagi tahu temperature dia and dia punya CP. So dia minta minimum flow rate of hot oil. So macam ni kita nak calculate, kita ambil dulu kita punya GCC. So kita kena identify limiting temperature kat sini. So basically apa yang kita akan buat is you punya supply temperature is 280 kan. So remember if it's 280, what is the T interval? Kalau delta T min dia 10. Kan? So at 200, thank you Akasha. 260, so around here lah. 275 kan. So kita akan lukis line dekat sini. So basically when we draw this line, you want to draw a, so remember hot oil ataupun flue gas, so dia akan jadi satu, dia akan jadi satu, so remember daripada sini kan. So kita akan cari mana dia punya starting point. So starting point dia is basically kita punya QH min, which is here, and then kita punya 275 is your hot oil being supplied, and we have to draw a line lah. So sekarang ni, kalau kita tengok based on this graph, mana dia punya limiting point? Kita tak tahu. Tak tahu. Nak je.
Tak tahu doktor.
Okay, thank you for the response. So remember limiting point tu, limiting temperature tu could be the GCC ataupun dia punya pinch. So sebab GCC ni macam normal. So remember ni tadi kita kena plot GCC, so sama step yang tadi. So sebenarnya kita akan nampak your minimum return temperature of your hot oil is basically your pinch temperature. So soalan dia minta calculate your minimum flow rate. So minimum flow rate, so remember delta H equals to M CP delta T. Kalau sebelum kita tengok delta H equals to CP delta T kan. Remember CP is equals to M CP kan. So kalau kita nak calculate kat sini, boleh tak kita calculate this value? Ke tak boleh?
Kurang clear doktor. Tak apa faham sangat.
Okay, tak faham, that's fine. Thank you for saying that. At least saya tahu. So basically kat sini, kita tahu dia punya QH min yang diperlukan is 750. Okay. So we need 750 of utilities kan. 750 kilowatt. So di delta H, the amount of, so M ni is basically your flow rate, the amount of hot oil that you can produce, that you require. So sekarang dia kata dia provide you punya CP, the temperature and the minimum flow rate. So basically apa yang kita akan buat is you gonna take the temperature, so put it here, based on dia punya T interval, and then you draw the line based on your QH min. So dapatlah kita punya first point. The second point would be your limiting temperature. So it is your pinch lah, so 145. So kalau kita calculate, you get 750 kilowatt of your QH min or amount of hot oil ataupun utility that you require equals to your M, which is the amount of hot oil yang you provide. CP, which is this value sebenarnya, dia dah bagi 2.1 kilojoules kilograms K, so 2.1 kilojoules per kilogram K. And then you have your temperature. So temperature difference ni is basically the gradient of your graph, the slope of your graph. So that's why you have to consider 275 tadi minus dengan kita punya pinch, so 145. Ada orang dia macam, Madam saya tak lukis gambar, saya ambil 280. So dia 750 equals to M 2.1 kilojoules per kilograms K. Dia ambil 280 minus 150. Boleh. Cuma make sure you use the same. Kalau you buat 280 minus 145, dia jadi salah. So it must be based on the same value lah. So you kan dapat dia punya M. So berapa kita punya M? Ini mass flow rate. Betul. So 2.75 kilogram per second. So kalau korang cancel unit, kilowatt is basically kilojoules per second. So kilojoules per second equals to kilojoules kg times your difference in temperature. So ni boleh buang, kilojoules boleh buang, dia jadi kilogram per second. So this is your minimum flow rate of hot oil. So dia senang je sebenarnya. So the reason why I want to show you this is to see that it's actually easy. So janganlah rasa overwhelmed bila dapat soalan macam ni. Okay ke untuk example ni? Okay kan, senang kan. You get to see macam mana kita nak calculate untuk steam and macam mana kita nak calculate untuk hot oil. Hot oil fuel gas lebih kurang lah. So tu saja basically untuk today's lecture. You guys had to get to see macam mana nak buat GCC daripada your PTA. And then you know how your GCC can actually show your utility requirement and your enthalpy and temperature terms. So you also get to see how your temperature differences are built into the construction. And so basically ni sebab kita guna T interval. So it's actually the best tool lah untuk kita punya utility placement. And kita boleh combine multiple utilities untuk utility placement. So you can actually use flue gas and steam if you need. You can use low pressure steam, high pressure steam, or medium pressure steams. And you can see macam mana balanced composite curve shows the actual true picture. So this is with all the utilities and utility range in the graph itself. So itu saja untuk this week's lecture, and I will post up the tutorial questions tomorrow, so you guys can try that out and see if you can actually do the questions yourself lah. So any questions?
So far, no question, Doctor.
So far no question. So it's quite easy and straightforward. So have a go through your textbook, I would say, sebab it would help you a lot with your understanding. Just message in the WhatsApp group ataupun post streams or whichever you prefer. So insyaAllah kita buat kelas kita dengan tasbih kafarah as well as